Good morning. I'd like to welcome you to the webinar on the OrganicA Apple Project by Lorraine Berkett of the University of Vermont. My name is Alice Formiga and I'm a coordinator for eOrganic. eOrganic is the organic agriculture community of practice with eExtension. We're a community of cooperative extension service personnel, researchers, ag professionals, organic certifiers, and practitioners. You can find all of our published articles, videos, and recorded webinars on our website at extension.org/organic_production. Before we begin, I'd like to briefly introduce our presenter, Lorraine Berkett, who's a professor in the Department of Plant and Soil Science at the University of Vermont, and who's the OrganicA Project coordinator. Joining us during the question and answer period following the presentation will be Terence, or Terry Bradshaw, also of the University of Vermont, who's the project orchard manager. After the presentation, which will last about 50 to 55 minutes, we'll be running a quick poll to give some feedback to the presenters, and then we'll have about a 20 to 25-minute question and answer session. So if you have a question at any time during the presentation, you can simply type it into the question box on your screen and hit return. If you don't see the question box, click the small plus sign next to the word question on your control panel to open it up. I'll be reading the questions out loud and we'll answer as many as we have time for. So now, Lorraine, I'm going to hand you over the screen control. So in just a moment, you should be able to control the screen. Okay, now you can click once and you should have the control. There you go.
Well, thank you, Alice, for that introduction. In today's presentation, I will cover some of the research results from the OrganicA Project, which involves the apple cultivars Ginger Gold, Honeycrisp, Zestar, Macallan, and Liberty. Before I get into the research results, I'll begin with an overview of the objectives of the project and how the research was set up, and what questions we were trying to answer with the research. The OrganicA Project is supported by a major grant from the USDA Organic Research and Extension Initiative. The project's official title is a very long and quite a mouthful, so we refer to the project as the Organic Apple Project, or the OrganicA Project for short. The project was started in 2006. Basically, we have been taking a new look at the potential opportunities and challenges of organic apple production in New England. Although there is significant interest in organic apple production in the region, there are very few certified organic orchards, in part because of disease challenges associated with McIntosh, the predominant cultivar grown in the region. However, recent shifts in consumer preference for newer or different cultivars have led to the planting of newer, different apple cultivars which have different disease susceptibilities. Thus, the basic rationale for the project was to determine the opportunities for organic apple production in orchards that are incorporating new or different apple cultivars, and examine these opportunities within the two major production systems growers are using to switch to new or different cultivars. That is, planting a new orchard with young trees purchased from a nursery, or top-grafting an established older orchard to new cultivars. The project was developed with input from growers from the region. We asked which cultivars are you planting and which are important for the future of the industry. And from that list, the cultivars Honeycrisp, Ginger Gold, Macallan, Liberty, and Zestar were selected. These are the cultivars we are studying in the two orchard systems. The apples in this picture are organically certified Zestar apples from the project harvested in 2011. Before I get into the project details, I'd like to acknowledge the members of the OrganicA Team. Members of the team include faculty and technical staff at the Universities of Vermont, Maine, and Arkansas. The individuals listed here represent the disciplines of pomology, plant pathology, entomology, soil health and management, ag economics, and organic farming. Not listed on this slide are the many growers who provide guidance and insight to the project, including the members of our advisory panel. The OrganicA Project would not be possible without funding from the USDA, not only the organic program, but also other agencies, and from the various universities involved in the project, and from apple growers. We very much appreciate your support. There have been some major constraints to organic apple production in New England. As I mentioned, we have apple cultivars such as McIntosh that are very susceptible to apple scab, and our wet summers are very favorable for infection and disease development. Also, there are arthropod challenges. One example is plum curculio management. Up until a few years ago, organic options for management of this insect were very limited. Reliable thinning materials in organic production are also somewhat limited. As you may know, in order to obtain a consistent crop from year to year, both in quantity and size, a recommended practice is to thin the crop so the trees don't get into biennial bearing cycle. And in organic orchards, this is a challenge to manage. These have been some of the constraints in organic apple production, and in the OrganicA project, we wanted to see if these remain constraints and whether there are economically viable options that can be used in the two production systems growers are using to establish new orchards and with the 5 cultivars mentioned. We started the orchard research in 2006 when we planted what we designated as Orchard 1 with Nursery Trees and top-grafted another orchard, which we designated as Orchard 2, to Honeycrisp, Ginger Gold, McCowan, Liberty, and Zestar. In Orchard 1, the rootstock is bud 9, except for Honeycrisp, which is on M26. In Orchard 2, the rootstock is M26, and the interstem, which was the original cultivar of each tree, is either Macintosh or Liberty. These two orchards are located at the University of Vermont Horticultural Research Center, commonly referred to as the Hort Farm. These pictures show how these orchards appeared in 2006. There have been 2 phases of the project to date. Phase 1 was from 2006 to 2009, which basically covered the orchard establishment years in each of the 2 orchards. We received organic certification in 2008. We are currently in Phase 2, the early bearing years of the orchards. Just a few more details about the setup of each research orchard. In Orchard 1, 240 trees were planted in 8 rows at a spacing of 5 feet by 15 feet in 2006. As I mentioned, there are 5 cultivars. There are 16 replications of each cultivar. Each replication consists of 3 trees planted next to each other. They're on, the trees are on bud 9 except for Honeycrisp, which is on bud N26. Trees are being trained using a vertical axe system. Because we have to run statistics on the data, the orchard was planted using a completely randomized experimental design. This is the map of the orchard. It indicates the location of the various 3 tree replications of each cultivar. Each box represents a tree. Now, for sure, this is not how a grower would plant an orchard. But to do replicated research, we have to use experimental designs. The cultivars are color-coded. You can see that some trees have died, but not many. The trees that have died are indicated by the black boxes. We had a problem with a weed cultivator that we were using, and it easily can take out a tree. But luckily, we haven't taken out many of the trees in this orchard with the cultivator. In this slide, you can see Orchard 1 as it appeared in 2011. We've had challenges in this organic orchard. The trees have not filled out their spaces as we expected. In other words, they have showed poorer growth than what was expected. Potential reasons for this include the rootstock, bud 9, may not be well matched to the specific site. The soil is a Windsor loamy sand. It is a very sandy site. Weed management posed difficulties during the initial years. Weeds competed with trees in the first year or 2 before we established the mulch strips. Also, there may have been some possible root damage caused by the use of the weed cultivator. Water stress may have impacted tree development. The orchard is irrigated, and now there's mulch underneath the trees, but the site is sandy, and there may be water stress at times. You can actually see the irrigation line that is about a foot or so above the surface of the orchard floor. And the trees have had high Phytophagous mite populations, which I will talk about later in the presentation, which potentially stress these trees. Again, the use of sulfur has been implicated in flaring mite populations. Because of the lack of growth that we were seeing in Orchard 1, in 2009, we started new research to address the potential reasons for this lack of growth. Dr. Lorraine, a member of the OrganicA team at the University of Maine, started weed management trials in Maine, comparing an organic herbicide with mowing and wood chip mulch. Terry Bradshaw, a member of the OrganicA team at the University of Vermont, started and completed a master's thesis to determine if applying kelp extract products, which are considered biostimulants, whether they would have a positive impact on tree growth. I will touch upon some of his results later in the presentation. Orchard 2 is a top-grafted orchard. This orchard was originally planted in 1988 with McIntosh and Liberty on M26. The tree row spacing is 10 feet by 15 feet. In 2006, a Vermont apple grower who was very good in grafting came to the orchard and grafted the existing trees with the 5 cultivars. So now the original cultivar, McIntosh or Liberty, is the interstem of each tree. Since we did not know whether the original cultivar would have an impact on growth, on graft survival, or tree performance, we used an experimental design that can detect whether the cultivar had an impact or has an impact on tree growth and other variables we are measuring. We used a randomized complete block experimental design where the blocks relate to the original cultivar. The questions we had in setting up the design of this orchard were, are there differences among the cultivars in initial survival of the science? Do certain cultivars perform better than others over time in a top grafting situation? Does what you graft onto, in this case McIntosh or Liberty, impact cultivar growth and productivity over time? This is the color-coded orchard map. Each small rectangle represents a tree. In this orchard we have 2 tree reps throughout the orchard of each cultivar. There are 190 trees were grafted. The tree row spacing, as I mentioned, was 10 by 15. The tree training system is a central leader. The same color code that we used in Orchard 1 we used here. You can see a number of trees have died in this orchard. Those are the blackened out spaces. This usually has involved Zestar and McCowan, and again I will touch upon this later in the presentation. And this just is a picture, a slide where you can see Orchard 2 as it appeared in 2011. It's quite a difference from the cut trunk with the 2 grafted science that we saw in 2006. In order to get at the questions listed on this slide, is organic apple production profitable and sustainable in New England with the knowledge and tools we have with these specific cultivars? And will there be a long-term difference in profitability between the 2 organic apple production systems under study? In order to get at these questions, we have kept detailed records of all the inputs for each orchard. Every time anyone goes into the orchard, it is recorded so we can look at the economics. We collect an enormous amount of data each year in the general areas listed on this slide: disease incidence and severity, arthropod pest damage, beneficial arthropods, horticultural data, measurements of soil health, and economic inputs. The orchards received organic certification in 2008. That was the first year we harvested a partial crop. Since then, we've had 3 years of harvest data covering the early bearing years of the 2 orchards, 2009, 2010, and 2011. In terms of types of horticultural data, we have collected trunk cross-sectional areas of each tree, and that's a term used by pomologists, horticulturists to refer to trunk diameter. So trunk cross-sectional area is trunk diameter. We've collected bloom density data, yield, and quality measurements of harvested fruit. Because of the time limitations today, I won't be able to give you some very quick snapshots, and I know I'm going very quickly through these slides, but there's a lot to cover, and I do apologize for going fast. But I do want to give you an overview of what we've learned about the cultivars in the 2 orchard systems. The growing seasons of 2009, 2010, and 2011 had very different weather, and thus performance was evaluated under diverse growing conditions. 2009 was cool and very wet, with delayed bloom and delayed ripening periods. 2010, we had a very early spring, advanced bloom, and frost was experienced during and soon after the blossom period. After the difficult spring, the rest of the season offered good growing conditions with some periods of summer heat. It was warm for Vermont standards, but adequate rainfall and good ripening conditions at harvest. 2011 started out extremely wet. It was actually the wettest spring on record. It was wet and cool, followed by a summer drought, then another period of record precipitation in late summer and early fall. So the 3 growing seasons were diverse. I do want to point out that Terry Bradshaw, who will be involved in answering questions at the end of this presentation today, superimposed an experiment across all the cultivars in Orchard 1 during 2009 and 2010, where he evaluated the potential effects of 2 kelp products on tree growth, tree vigor, and yield. The materials tested were Stimplex and C-Crop 16, both kelp extract materials. You see the products listed here. Both materials contain cytokinin isolates from Ascophyllum nodosum, or kelp. Terry used a split plot experimental design with the 3 treatments, the 2 kelp product treatments and a non-treated control. Treatments were applied to the foliage at recommended field rates during the 2 growing seasons. Bottom line, for the majority of the horticultural parameters measured, no significant effect from the kelp extract products on tree growth, crop yield, and fruit quality were observed. Therefore, the data that I will present from Orchard 1 today includes all trees, regardless of the kelp treatment. So on to some of the measurements of tree performance. Trunk diameter, or in other words, trunk cross-sectional area, is a standard measurement of tree size that was assessed at the end of each growing season on each tree. TCSA, which stands for trunk cross-sectional area, is an important measurement used in the calculation of relative yield between different trees. From 2006 to 2008, trunk cross-sectional area was not statistically different for any of the cultivars. In 2009, Honeycrisp had attained a larger trunk cross-sectional area than Zestar, and in 2010, Honeycrisp trees had greater trunk cross-sectional area than all cultivars except ginger gold, and this is the data illustrated in this table, this graph. Canopy height and width were also measured for each tree. In addition, the length of the current season's vegetative shoots was also measured each year. The following slides show the results of for each cultivar for these measurements. These are data from 2011 for Orchard 1 for tree height, spread, and shoot length. You have cultivars on the left, tree height, meters, tree spread, and shoot length. In terms of ranking of the cultivars, ginger gold trees had greater height, tree height, width, and terminal length than other cultivars, although it ranked the highest, although the measurements were not always statistically different from the other cultivars. The shortest trees were Liberty. Each spring, blossom density was rated on a scale of 0 to 5, where 0 meant no blossoms, 5 meant that over 90% of the spurs had blossoms. This slide shows the bloom ratings for each cultivar for 2009, 2010, and 2011. It should be noted that there was no hand thinning during 2009 and 2010 in Orchard 1 because of the kelp study being conducted in this orchard. And the orchard did appear to get into biennial bloom cycle. You have the ratings here, again 0 to 5, 5 being over 90% of the spurs with blossoms. You have a lower ratings, 2010 overall, and then more higher ratings in 2011. Looking at the data, what stands out on this slide? Well, Honeycrisp usually had the lowest bloom rating of all cultivars. If you go across, you can see that Honeycrisp had the lowest, usually had the lowest bloom rating. And 2, Zestar appeared to be less affected in 2010 by the lack of hand thinning than the other cultivars. Its bloom rating has been consistently good across all years. Fruit yield in 2011 in Orchard 1 was low by commercial standards for an orchard of this age. As I mentioned earlier, Orchard 1 has not performed as well as expected. Ginger Gold and Honeycrisp had the highest yield in number of fruit. kilograms of marketable yield and marketable yield efficiency. Yield efficiency is in the third column of this chart. It is calculated by dividing the weight of the crop by the TCSA to standardized yield measurements across trees of different size. And just as a side note, 1 kilogram is equal to 2.2 pounds if you'd like to make that conversion. While not analyzed statistically, the estimated mean fruit yield in bushels per acre can give insight on the relative performance of the cultivars. And the estimated bushels per acre is in this last column on the right. In 2011, Ginger Gold and Honeycrisp produced 125, an estimated 125 bushels per acre and 222 bushels per acre respectively. And you can see that Zestar had only an estimated 91 bushels per acre in 2011. Another item to notice on this slide is that the pre-harvest drop is relatively low, relatively high for Liberty. That's in this column here. It's pretty high. When we look at marketable yield efficiency across the 3 years, so you have 2009, 2010, 2011, Ginger Gold has been the most consistent top performer of the cultivars. Yield efficiency for 2010 was low, we believe, due to the frost at bloom. But the increase in yield efficiency from 2009 to 2011 is encouraging because it shows all cultivars are increasing in yield over time, even when accounting for increased tree growth. So some conclusions regarding Orchard 1. Orchard 1 has had some challenges during the study. Its tree size and yield are less than would be expected for the orchard's age. Overall, in 2011, Ginger Gold and Honeycrisp are performing better than Liberty, McAllen, and Zestar at this point in time. In Orchard 2, the top-grafted orchard, tree survivability, has been an important component of performance. Since grafting, some trees have died or have not grown as well as others. Trees are assessed annually for tree health on a scale of 0 to 3, where 0 is dead, the tree is dead, and 3 is the trees are growing well and have developed nice sized canopies. It's a very subjective rating, but it's done every year. It's done by the same person every year. This table includes the proportion of all trees that are growing well, that had a rating of 2 or better. Basically, they're growing well. You can see in the rating the proportion of trees that had a high rating in 2009, and then again that same data, type of data in 2011. You can see that there's really no statistical separation or differences between the different cultivars. But from a practical standpoint, you can see that both McAllen and Zestar, approximately 40% of McAllen and Zestar trees are not growing very well compared to Ginger Gold and Honeycrisp. In other words, there are only 61% to 63% of the trees that are growing as well or comparable to Ginger Gold and Honeycrisp. However, the decline appears to be stable with similar status in 2009 and 2011. This indicates that the trees that survived the initial stress of grafting have continued to grow well under organic management. It should be noted that no difference between the blocks were detected. In other words, the original cultivar, which was either McIntosh or Liberty, appeared not to have an effect on tree survival and growth. Actually, for all the horticultural parameters measured, there were no cultivar by block interaction. The cultivars performed similarly on either interstem. In terms of yield, in 2011, Ginger Gold ranked the highest in number of fruit per tree and net weight per tree, although statistically it did not separate out from Zestar or Zestar and Honeycrisp for those 2 parameters respectively. Ginger Gold also ranked the highest in estimated bushels per acre. Again, this is an estimated yield per acre given the yield per tree. Honeycrisp ranked the second in estimated bushels per acre. Similar to Orchard 1, Liberty had a significantly higher net weight of fruit on the ground per tree. I do want to point out that the yield efficiency calculation is very low with this orchard. And my horticultural colleagues point out that yield efficiency for top-grafted trees may not be a valid measurement because of the structural makeup of the tree. You have the original rootstock, the original cultivar, which is now the interstem, and then the grafted scion. Where one takes the trunk cross-sectional area will impact the yield efficiency calculation. And where we are taking this measurement on these grafted trees may not be a good indication of tree growth when it's put into this calculation. Comparing the estimated bushels per acre across the 3 seasons, we generally see increases in 2009 compared to 2011 compared to 2009 for the different cultivars, except for Liberty, where the estimated bushel per acre has declined. The orchards are not designed for direct comparison, but looking at general estimates of bushels per acre for each orchard in 2011, we can see that Ginger Gold and Honeycrisp appear to be performing better across both orchards. So then some conclusions. The yield efficiency calculation does not appear to be a good representation of yield performance in this top-grafted orchard. There were no cultivar by block interactions for any of the horticultural parameters measured. The cultivars performed similarly on trees with either McIntosh or Liberty interstem. Overall, Ginger Gold and Honeycrisp are consistently performing better than the other cultivars. And as we had in Orchard 1, in our minds we have questions about the effects of lime sulfur and sulfur sprays on photosynthesis and effects on tree growth and crop yield in this orchard, and on flaring mite populations. These materials may also be a factor in the level of fruit rots we are seeing in both orchards. I'll touch upon this in a few minutes. Now on to some of the disease and arthropod results. We have been collecting data to determine differences among the cultivars in incidence and severity of the various pests in the 2 orchard systems. In each of the orchards, we have incorporated current IPM techniques to monitor insect and mite populations to determine if thresholds have been reached. I have listed on here organic IPM. What do I mean? Organic IPM to me is an approach to managing pests that integrates organically approved biological, cultural, physical, and chemical tools in a way that minimizes economic, health, and environmental risks. We have conducted cultural practice in both orchards that reduce potential overwintering inoculum of apple scab. You can see in the results of flare mowing in the center picture. And we perform other recommended practices, such as proper pruning, training, sanitation, proper nutrition, proper irrigation, that will impact or influence diseases and insects. We have used computer models that incorporate weather data to track development of various insects and to determine what infection periods for apple scab and fire blight. When intervention is warranted, we have used accepted, organically approved fungicides and insecticides. These are the fungicide options we have used in both orchards. We've used a delayed dormant application of copper for fire blight management, and I believe in 2010 we did use streptomycin because of a high risk of fire blight. We have used sulfur and liquid lime sulfur for apple scab management. And we have used quite a number of fungicide sprays targeted at apple scab each season. LLS stands for liquid lime sulfur, S stands for sulfur. These sprays were based on disease development models, predictions of ascospore release, and predictions of when conditions would be favorable for infection. Again, we have usually very wet conditions that are very favorable for disease development in most years. You will see from the data, some of the data that I'll present, we can manage apple scab on the fruit, but the question is at what biological cost? In terms of options to manage arthropods, these are some potential options we have considered or used. We have used many of these depending on the situation, but not all of them. I do want to emphasize that it is of critical importance that before anyone uses a technique or material, that you check with your certifying agency to confirm it is approved and to ensure compliance with organic regulations in your state. It is very important to do so. In terms of our experiences in disease management, apple scab is a major disease in New England. It is a major focus of the disease management program. Here you see data, percent of leaves that had apple scab lesions. Honeycrisp, you can see Honeycrisp had low levels of foliar scab in all 3 years. Here's Honeycrisp in Orchard 1, next to Liberty, and Honeycrisp in Orchard 2. It had low levels of foliar scab in all 3 years, and that's a good thing. The cultivar appears to have some natural resistance to scab. Liberty is a scab-resistant cultivar, and one would expect not to see scab on this cultivar, but not seeing it on Honeycrisp is very good. Ginger Gold usually ranked the highest in level of foliar scab, but this was not always significantly different from the Callan or Zestar. Note that in general there was a higher incidence of foliar scab in the wet years of 2009 and 2011. But this was not quite the situation for fruit scab. This is the data for fruit scab. Statistical differences among the cultivars occurred only in 2009 for fruit scab, both in Orchard 1 and Orchard 2. In 2010 and 2011, there was relatively low levels of fruit scab. Levels were below the 1% wholesale threshold and within range for a direct farm market grower in those years. Even with 2011 being a wet year, we ended up with relatively low levels of scab. We were able, apparently, to manage it pretty well. Looking at 2009, the year where scab was at a higher level, again, Ginger Gold ranked the highest in level of fruit scab, but was not significantly different than the Callan. What caused this level of fruit scab in 2009, which again was also another wet year, particularly in Orchard 2? Well, we realized too late that we were not getting good coverage in the top of the Orchard 2 trees in 2009. These are pictures of the orchards after a kaolin clay application. Kaolin clay is used for arthropod management, but also allows you to assess coverage by your sprayer. Here's the Orchard 1. The trees are white from the kaolin clay. And in Orchard 2, you can see sort of a green band on the top of these trees. We were not getting good coverage with our sprayer. We realized the sprayer was not well matched for the tree size of Orchard 2. Needless to say, we got a new sprayer and also reduced the height of the trees in Orchard 2 before the 2010 season. And we believe this has helped in managing fruit scab. Rust diseases have emerged as a concern for both orchards. We have a complex of rust diseases in those two orchards, including cedar apple rust, hawthorn rust, quince rust, and Japanese rust. This is the incidence, the data for the percent foliage that have scab, scab lesions, rust lesions. Foliar rust incidence can be very high. Rust emerged as a major challenge, and you can see in this slide incidence ranged from 5 to 55% of the foliage having rust lesions. And you'll see in the next slide the range on fruit was from 0 to 39% of the fruit with rust. Honeycrisp or Ginger Gold ranked the highest in both orchards in incidence of foliar rust. In terms of rust lesions on the fruit, Ginger Gold ranked the highest in incidence, but the level was not statistically different from Honeycrisp or Liberty in certain years. Of concern is the levels of rust observed in 2011 in particular. You can see that they were just very high. This is rust lesions on the fruit. The fungicides which we did use during the growing season, the sulfur and liquid lime sulfur, did not manage this situation. Fruit rots are also a concern in both orchards. Fruit rots include decays caused potentially by a number of fungi, including the causal agents of white rot, bitter rot, and black rot. In our assessments, we attempted to count only rots not associated with skin punctures caused by physical injury or insects. Before I present data from Orchard 1 and 2, this is one parameter where there was a difference in the kelp extracts study that was conducted in Orchard 1. That difference was only seen on Honeycrisp and only in 2009. In 2009, trees treated with either of the kelp extract products had numerically greater rot incidence than non-treated trees, but only in Stimplex treated trees was the percentage of rotted fruit statistically greater than the non-treated control. Again, this was only seen on Honeycrisp and only in 2009. So this is the results here. The Stimplex had statistically higher percentage of fruit rots than the non-treated Honeycrisps, but there were no other differences in any of the other cultivars. Now the slide that presents Orchard 1 and Orchard 2 data for fruit rot. You can see that incidence of rots were variable across the years and across the cultivars. We really can't come up with too many conclusions of differences between the orchards or the cultivars. However, in general, incidence of rots appeared higher in Orchard 2 in 2010 and 2011 for all cultivars compared to Orchard 1 here versus here. And orchard trees, this may be because orchard trees have a higher density, higher canopy density. Perhaps this fruit remained moist longer. In Orchard 2, there's a little bit more dead wood or decaying trunks than Orchard 1 from the trees that have declined over time. We have also had an increasing population of codling moths, and some of the increase in incidence of rots may be because of nibbling of larvae, which then facilitates the rotting of the fruit. And again, whether we get getting the sprays that manage codling moth into the trees as well as we should. Orchard 2 is also the orchard closest to a significant inoculum source early in the study. In our experience with these organic orchards, we have become more aware of the surrounding ecosystem and potential sources of fungal inoculum and reservoirs for insect pests. There was a collection of ornamental crab trees that were not managed on the farm right next to Orchard 2, and they were just polluted. These crab apple trees were just polluted with fruit rots and damaged by insects. We did remove most of the crab apples, and also on the farm we also removed the junipers on the farm, which junipers are an alternate host for cedar apple rust. And so they could have provided inoculum, initial inoculum for some of the rots that we are seeing, again, getting into the trees and causing cankers and potential source of inoculum. Here are some of these are crab apples, the rots on the crab apple, scab, and some insect damage. Regarding some other diseases, in general, when sooty blotch and fly speck were observed, Liberty and McCowan had the numerically highest incidences, although not statistically different from the other cultivars. Powdery mildew was basically non-existent in the two orchards over the 3 years. Powdery mildew usually is not a serious disease problem in northern New England as it is in other regions. Our very cold winters are a factor in survival of the overwintering inoculum. It's a negative factor. That is not to say that certain cultivars cannot have high foliar incidence. In orchards 1 and 2, the numerous applications of sulfur would also have had activity against powdery mildew infections. Regarding fire blight, there were no significant differences among the cultivars in fire blight severity in 2011, the only year of the study in which symptoms were seen. Incidence was low and observed on all cultivars in Orchard 2. I've touched upon some of the disease issues. Now on to the arthropods. Again, I'll only be able to give you very quick snapshots within this presentation. In assessments of foliage in August of each season, we have consistently found high European red mite populations. There's no statistical difference among the cultivars in any of the years. Incidence is very high on all cultivars, and they can't get much higher than 100% this past year. It's pretty high. Phytophthora mites are a serious concern in both orchards. The high populations are troubling because mites can impact tree growth, yield, and lead to fruit drop. Bronzing of the foliage was evident in both orchards. We have tried seeding both orchards with T. pyrrhi, which is a predaceous mite that can feed on European red mites, but we still have high European red mite populations. Sulfur, lime sulfur, and kaolin have been associated with flare-ups of Phytophthora mites in other research studies. And we believe in particular the lime sulfur and sulfur we have used for disease management may be a factor in the high mite populations we are seeing. Kelp extract applications showed no effect in 2 years of the study in Orchard 1 regarding European red mites. We are planning to do research trials in Orchard 1 and 2 where we reduce the use of fungicide sprays. We'd like to determine where the tipping point is in terms of managing disease, but trying to minimize the potential negative non-target impacts of the fungicides. And this is a slide that I just talked about. At harvest, we collect a subsample of fruit from all the trees in each orchard and examine them for arthropod damage. In the picture you can see Terry Bradshaw. Morgan Griffith is recording the data. Terry does all the assessments. He assesses all the fruits so there is consistency in the evaluation. Puncroculio is a major pest of apples. We use kaolin clay to manage the damage from the insect. This slide contains the percentage of fruit with puncroculio damage at harvest. Differences among cultivars were detected in 2010 and 2011 in Orchard 1 and only in 2011 in Orchard 2. But there were really no consistency in which cultivars had highest or least amount of damage. It was just very variable. An anecdotal side note, the damage that did not appear, the damage that we did see did not appear to have a big effect on grading based on using US number 1 as the highest grade and the assumption of retail or farm stand sales of the fruit. Tarnished plant bug. This shows damage on fruit assessed at harvest. The only year where differences were detected among the cultivars in percent incidence of fruit damaged is in 2010 in Orchard 1, which is right here, where Ginger Gold has significantly higher incidence of damage compared to Liberty. Again, as an anecdotal side note, the damage did not appear to have a big effect on grading based on using US number 1 as the highest grade, and again the assumption of retail or farm stand sales of the fruit. Apple maggot. Apple maggot is also a serious pest of apples. We use baited red sticky spheres to monitor activity and determine if thresholds have been met before intervention. This is the percent fruit with damage at harvest. Incidence of damage is relatively low in all years, which is a good thing. In Orchard 1 in 2010, Honeycrisp trees fruit had significantly higher damage than Liberty, Macallan, and Zestar, but was not statistically different from Ginger Gold. In 2011, the only cultivar where damage was observed was Zestar in Orchard 1. This is Zestar 2011. It was the only where we saw any damage. And here in 2010, you had Honeycrisp had the highest amount of damage. It was not different statistically from Ginger Gold. It was different from the others. In Orchard 2, Honeycrisp ranked the highest in damage in all 3 years, but statistically no differences were detected. So you go across, numerically you had the highest, ranked the highest, but it was not statistically different from the other cultivars. This is a data set where for fruit on trees treated with kelp extract did have a different incidence of damage than the non-treated fruit. The treatment effect was only seen in 2009, And trees treated with either of the kelp products had significantly less apple maggot damage compared to the non-treated trees. Here's that line right here that tells the story. No damage was observed on the kelp, and this is the percentage, small percentage, but this is percentage of fruit on the non-treated controls that had apple maggot damage. Possibly there was an olfactory effect that may have deterred ovipositioning. Low incidence in insect presence or damage, and no consistent difference among cultivars were observed for green apple aphid, leaf miners, European apple sawfly, and rosy apple aphids. Only in Orchard 2 and only in 2009 were differences detected among cultivars in percent incidence of white apple leafhopper damage. Ginger gold had significantly higher incidence of damage than Macallan, and the damage was 6% versus 1.4% respectively. We do have a challenge with the relative high incidence of damage to the fruit by Lepidopteran larvae feeding on the surface and or tunneling into the fruit. The larvae of a number of moths can cause damage, including banded leaf roller, red-banded leaf roller, and codling moth. We are particularly concerned about codling moth. Our monitoring with pheromone traps in the orchards indicate that populations in the orchards are high and increasing. The following slides show the average week trap captures in Orchard 1 and illustrate how the numbers are increasing. These are the weekly trap captures in Orchard 1, and this scale here is the same scale that will be used in the next two slides. So you see an increase in 2010 and a further increase in 2011 of trap captures for codling moth. Another way to look at the data or look at the codling moth trap capture increases is to look at the average seasonal total of codling moth caught per trap in each of the orchards. Note that included in this slide are trap captures from a non-organic orchard on the farm. There's a column for non-organic IPM seasonal total of codling moth per orchard per trap. And you see even there it's increasing. It's increasing Orchard 1 and increasing Orchard 2. And we have heard reports of codling moth increasing in general in the region in various orchards. So codling moth is of concern. Here you see the percent fruit with internal lep damage, primarily codling moth, but oriental fruit moth damage can't be ruled out since we do catch some of these in some of the traps. Incidence of damage is especially high in 2010 in both orchards. So here and here. Differences were detected in most years among the cultivars in both orchards, but the differences are not consistent. Of interest is that even though the captures were high in 2011, overall damage appeared to be lower in 2011 than 2010, which is a good thing. In 2011, only in Orchard 1 were differences among cultivars detected, and in that situation, Zestar had a higher incidence of damage than the other cultivars. That's what you see here. What did we do differently in terms of management in 2011 for codling moth? Well, we have to go back to 2010. In 2010, we stopped managing codling moth too early in the growing season and incurred more damage. We goofed up. In 2011, we made sure we monitored and managed the insect for the whole growing season. We made sure it was on our radar screen. We also used codling moth granulosis virus for the first time this past season in Orchard 1 and 2, but we do not know whether this was also a factor in what we saw in terms of damage. We don't know how effective it was in managing damage. We are going to explore using mating disruption to improve management in the future. I do not want to end the presentation on arthropods without saying a few words about the beneficial insects observed in the orchards. Biological control is occurring. In Orchard 1 and 2, I have seen more ladybug beetles than I have ever seen in an orchard in the 27 years I have been working in apple orchards. Their population fluctuates during the growing season, but they are there. And as I pointed out earlier, we have seen very few green apple aphids, and when we do see them, the predators are right there with them. This is just another slide with pictures of beneficial insects. You can see orange cecidomyid larvae feeding on aphids, and you can see some dead bodies strewn about on this slide. Pictured also is an adult ladybug beetle and an immature. And in the center of the slide is an aphid line, right there. The immature stage of the green lacewing insect, which is a chrysopid, and it feeds also on aphids and other insects. It's an exciting time. It's very exciting to see these in the orchards. We rarely have seen rosy apple aphids, but again, biocontrol was evident. Here are two pictures of rosy apple aphids and with huge surface fly larvae that are feeding on the aphids. Here you got one there, and you got one there. And you can also see some small orange cecidomyid larvae there also feeding on the aphids. I do not have time to present results from Dr. Renee Moran's research into organic weed management. A summary of her results is on the OrganicA Project website. The web address is listed on this slide, or you can go to an internet search engine and type in organic apple resource, and the website should be listed within the top few listings. Dr. Heather Darby has been monitoring soil health in both orchards each year. Her summary is also on the OrganicA website. The orchards have produced beautiful fruit, but significant challenges remain. We are currently analyzing the economics of each orchard to address the questions that I mentioned earlier in the presentation. One, is organic apple production profitable and sustainable with these specific cultivars? And two, will there be a long-term difference in profitability between the two organic apple production systems that we are studying? We have identified 5 challenges, and these are listed on this slide. The potential non-target impacts of sulfur and lime sulfur used in scab management. These are a concern. Rust management, how can we effectively and sustainably manage rust diseases? European red mite management, will reducing sulfur and lime sulfur, liquid lime sulfur applications mitigate mite concerns? How can we better manage fruit rots in organic apple orchards? And codling moth management, how can we better manage this insect? To start to address some of these challenges, we will be setting up trials in orchards 1 and 2 to look into ways we can reduce the use of sulfur and lime sulfur yet still manage scab. Also, we planted a new high-density orchard in 2011 on the farm. It contains a selection of the most promising scab-resistant cultivars, and we'll be evaluating their potential for organic apple production. These are pictures of the new high-density organic research orchard we planted in 2011. We've designated it as Orchard 4. The bottom picture here shows its relationship to the other orchards. This is Orchard 4. This is the top-grafted orchard, Orchard 2. And in the back, you can just barely see Orchard 1. It looks like it might have had a surround application, a kaolin clay application. This is Orchard 4. The trees are on M26 rootstock. The tree spacing is 4 feet by 15 feet. A tall, spindle, slender pyramid training system is being used. Since all the trees that we've planted are scab resistant, we'll be able to drastically reduce our use of sulfur and lime sulfur in this orchard, and hopefully this will reduce the potential non-target impacts of these materials. We will see. We will continue to post research summaries of the various aspects of the project on the OrganicA website, including the economic analysis of the cultivars in the 2 orchard systems. We have just recently uploaded a resource entitled A Practical Guide to Organic Apple Production on the site. This guide is a work in progress, and your comments and suggestions are always welcome. Also on the website are the archived issues of Orchard Observations. Orchard Observations is sort of a newsletter/blog of what is happening in the organic orchards during the growing season. Let's see if I can. Doesn't seem to want to, the slides don't seem to want to go. But the next slide you would have seen you would have seen just an illustration of one issue of the Orchard Observations. There it is. There we go. It's 2 pages of this issue came out in July 26th of 2011. It illustrates just 2 pages of a 4-page issue where go out in the orchards, see what we see, take pictures of it, put together our trap captors, other things that we're seeing, and put it in a quick issue, get it out. We send it out via email to members of our listserv, and then we post it on archive it on our website. If you'd like to get on the listserv, just send me an email and indicate you want to get on the Orchard Observations email list. The email list is not shared. I use it to send out Orchard Observations and notices of meetings and other appropriate information. My email address is on the bottom. Again, before closing, I do want to thank the sources of funding for this project, in particular the USDA Organic Research and Extension Initiative. We are very grateful for the support. And I also want to thank you for your attention. I know I've gone through all the slides very, very quickly, and I've presented a lot of information, maybe too much, but I apologize for that. But we're excited about the project, and we want to let you know what we've learned, the results, and again, the website will have further summaries. The economic analysis is going to be a big one, and we'll go from there. So I thank you very much, and I believe that Alice will be asking some 5 questions that would really be great to get your input on. So with that, I will conclude.
Yeah, thank you very much, Lorraine. I just wanted to pull up those questions. So I'm just going to launch a very quick poll, and then you'll see that on your screen, and you can just fill that out. So each one will only be up for about 20 seconds or so. Lorraine would be very interested in your feedback about whether or not you have a certified organic apple orchard. Please select one. And then we'll pull up another question in about 1 second or so. Let me just close this one. Okay, thank you. And let's bring up the second question. Okay, here we go. Has today's webinar on the OrganicA Project increased your knowledge? And there's a couple choices there. Please select one, very much, moderately, slightly, or not at all. So if you could just quickly check on that. We'll leave that up for another few seconds. I think there's 5 in total, so a couple more to go. Thank you very much. All right, we'll close this one. Okay, now we're going to pull up number 3. Here we go. Do you think that the ongoing OrganicA Project research will enhance the potential to grow higher quality organic apples? Please select one. Yes, no, or unsure. Okay. We've got 2 more here. They're very quick. All right, thank you. And number 4. Here we go. If you have an orchard, do you plan on using the information presented today? Please select one. Yes, no, or unsure. Okay. All right, and in just a moment we will pull up our final poll question. Okay, and oops, let's see, here we go, number 5. How would you rate the importance of continuing organic apple research and extension outreach programs like OrganicA? Extremely important, very important, moderately important, slightly important, or not at all important? So just if you fill that out, we will soon close all of these polls, and then we'll move on to the questions and answers. And I just wanted to let anybody know who came on later in the presentation that the way you can ask questions is to type a question into the question box on your screen and then click return. And we'll get that question, and then for the next 20 minutes or so we will read Lorraine the questions out loud, and she will answer as many as she can. And Terry, we are going to also have Terry on with us as well. Terence Bradshaw, who works with Lorraine at the University of Vermont. We saw his picture earlier. He'll be on hand to answer questions as well. So let me move on to the first question. Could you repeat the compound you used for coddling moth again? And also, if you could comment on spinosad and Sid-X.
Well, why don't I let Terry Bradshaw answer that question. He's the hands-on orchard manager, and he has in-depth knowledge on materials we've used and how we've used them throughout the 3 years of the study. Terry?
Yeah, thanks, Lorraine. Actually, let me make sure my microphone is on, correct?
Yep, we hear you.
Okay, good. I had it muted. And we have not applied the, it hasn't been a study of spray materials against codling moth, so we haven't been able to test in terms of the research design, material A versus material B. So we can only couch that in terms of what worked in any individual year. We have used Dipel, which is a BT product, Bacillus thuringiensis product, quite a bit in our spray programs, mainly targeted at numerous Lepidoptera larvae. It's effective only against Lepidoptera, of which there are many that feed on trees or on fruit and trees. But it's pretty well known in the literature that it's not really the best material against codling moth, because a codling moth larva, there's only a few hours between the egg hatching and the larva taking a bite into the apple and tunneling into it, so they don't eat a lot of the material, which it's a stomach poison basically, derived from a soil bacteria, and they need to eat a fair amount for it to be effective. So the use of Dipel or BT, Dipel is just the trade name of the product we use, hasn't really been targeted at codling moth. I think it might have some effect, kind of a low-level effect, but that's just conjecture on my part. We relied earlier on Entrust, which is a spinosad product, another product made from a fermentation process of the natural microbe, and we were using that early on, 2009, 2010, and it seemed to have some efficacy, mainly, really, I would almost think against apple maggot fly, which is kind of the window that we time it at. But it is another Lepidoptera-specific material, fairly active against it. But again, the literature doesn't show it's really effective against codling moth. And I think we were lulled into a false sense of complacency over the years because our codling moth population, wasn't particularly huge. If you saw that graph, the charts from 2009, you watch how it scaled up over the years. In both the organic and the non-organic conventionally managed orchard, which is maybe 1,000 feet away, our pressure is certainly increasing. This is after removing roughly 100 unmanaged crab apples surrounding the planting. So our inherent pressure is going up. So this year we kind of pulled out all the stops on codling moth management, and we used a newer material. It's codling moth granulosis virus, and there's a number of commercial products that contain this this particular virus, and it's species specific. So it's not just Lepidopteran specific, but it's specific to codling moth, and maybe with a little bit of efficacy against oriental fruit moth, which is closely related, but it's not really targeted toward oriental fruit moth. This is a virus. Again, the larva needs to eat it, but there's a much lower effective dose. But it has to be present as the larvae are hatching. And if you go back in Lorraine's slides, you can see the charts that by the time we got to 2010 and especially 2011, we were catching many more moths per week than you normally would in an ideal commercial situation. So. Yes, we did see a real reduction in codling moth infestation at harvest this year. I'll also say it was an extremely expensive program that we applied this year. It would not be economically feasible in a one-year situation. But with organics, you really need to look at managing the whole farm over multiple years. So trying to put a little extra effort into reducing the population this year will have impacts in the certainly the next year, if not the next few years. But that's probably the material that was in question was granulosis virus. Did I answer the question?
Hope so. If it doesn't, you can type in more questions. We do have quite a few questions coming in, so we'll get to as many as we can here. This questioner wants to ask what you think about diversity. In other words, do you think growing apple trees with other horticultural trees to combat arthropod problems would help?
Yeah, there's some research out there about companion plantings, and especially some of the research that I've seen refers to trees that have extra floral nectaries, and these are often stone fruits, and especially plum trees. It becomes difficult to manage multiple crop plantings on a commercial basis, and that's what the premise of this project is on. The idea is that you have a grower, which you often have a grower who will have maybe 4 to 10 acres or more, whose primary income is growing fruit either for local distribution to a farmer's market or to co-ops, or having an on-site farm stand. So it becomes very difficult when when you mix up plantings, meaning the crops that are up there, in terms of labeling of materials. When you think about something like a sulfur material that you might be spraying in the apples, that can be especially phytotoxic to a stone fruit, and it may not be labeled for the stone fruit at the time that you need to apply it to the apples. So if you're growing a crop that you're also harvesting, that becomes quite difficult. Now the use of flowering plants in the ground cover, that's a little bit different story, and there's a fair amount of research out there, and it isn't fully conclusive, but there are some indications that flowering ground covers can help in terms of attracting beneficial insects. On the flip side, it can also attract insects such as tarnished plant bug that can do damage to the fruit crop, and it can also keep bees in the orchard at a later time than you want. And I think especially at bees are essential in orcharding without question. But when it's time for say petal fall applications of whatever material you might be using, say spinosad for example, spinosad is known to be harmful to bees, and so encouraging bees in there in that window is kind of a dance you do. We often spray in the middle of the night, and a lot of your material labels will give language around that to say that you can or cannot spray when things are blooming, and if they are, spray at night, or usually at night when the bees are not foraging. So it's kind of a tricky dance, but I do see a place in some areas for diversified ground covers, but we haven't explored that too much in this orchard.
Okay, next question. This is probably from a grower. It says, why should I go organic with the data given? It does not seem profitable. And then, we have another related question, which was, how much did it cost to spray the orchard in a calendar year? So if you could discuss the economics of this a little bit.
Right. Let me open up my economics notes on the side. Well, first I'll point out, the final economic returns are not in on this orchard, mainly because any orchard, even the best, best growing, most high yielding non-organic orchards, under best case scenarios in regional studies in the Northeast, it usually take about 11 years minimum before they're paying back. So if you look at this right now, you're going to see that you're still losing money, but any grower would be in this situation. That said, so we haven't really put too much out on the economics at this point. We are working on that for the progress report, but I can say, in particular, in Orchard 2, where the planting costs were quite a bit lower. That was the top-grafted orchard. The planting costs were much lower than in Orchard 1, where we had to buy what would the equivalent of 600 trees per acre and install trellises. Do a bunch of prep work to the ground and whatnot. That was an expensive orchard to plant, and newer high-density orchards tend to be quite expensive. Orchard 2 was a lot cheaper to plant or to graft over, And we're getting yields in there that are high enough that we're actually seeing, and I sit down with our economist to go over this. I was concerned last year when we've been seeing the curve heading in the right direction. We spent a fair amount of money planting the orchard, so the curve kind of heads up in terms of costs, and then you see it come down as you start to bring money in. Last year it was going backwards. We were seeing that we were losing money for the first time in a couple of years. We were losing ground, but that really is because of the frost that we had in the spring of 2010, which really is kind of a problem. But as our economist points out, if you're looking at real-world situations, occasionally you're going to have a frost. You might have a hailstorm, which we had a hailstorm in 2009. Both of those are fairly rare at this site. This is actually a very good site for growing apples, but it's real world. So I don't think we can just draw the line out from what we've seen in 2010 or 2011 and assume that we're going to continue, at that rate of yield and income and expense. But we're heading, in that orchard in particular, we're heading in the right direction. So I'm not totally down on organic orcharding at this point. What I'll mention for costs, and I'm just looking, I'm looking on my computer, and I've got my spreadsheets keep going thicker and thicker and into various realms. So if it takes me a second to find the data, I can bear with me. Generally speaking, and I'm just going to look at income. Let's see, net input costs, and I'm on the Orchard 2 tab. Total input costs in 2011. This is spray materials, fertilizers, things like that were, $1,300 per acre, which is relatively high. And the real cost in that was the codling moth program. And I'd have to really go deep in my spreadsheet to pull out just those particular materials. But as I remember, it was on the term of many hundreds of dollars per acre, just applying the Sidex, the codling moth granulosis virus, as well as Entrust, as well as Dipel, to try to get that down to a reasonable level, because we were concerned that the 40% codling moth damage the year prior, was not sustainable, and if we kept having those larvae overwintering, that we would have a problem for years to come. So hopefully a grower would have spent an extra $50 an acre back in 2010 and done a better job controlling that generation, and wouldn't have had to spend the amount that we did in that orchard in this past year. That's just a quick number I was throwing out. Let me look at Orchard 1. The interesting thing in terms of costs, Orchard 1, what's been a really troublesome cost over the years, high cost I'll say, has been, in terms of both dollars and in terms of effort and labor expended, has been weed management. And we've finally settled down on realizing that we just cannot hand weed that orchard. We've used multiple tactics in there, and the years when we were strictly hand weeding or putting a lot of hand weeding into the orchard, we would get extremely high labor costs in order to get the effectiveness we needed. So mulching has, I think, really cut the cost down. Even if you're paying for mulch, we buy radial chip mulch from a local tree service. I have a good relationship with them. We get it for a very, very low cost. So that's really saved that. So that kind of artificially inflates the cost or the lack of return in that orchard. If I can add, if you want to clarify any other specific costs, please add to the question there. But I don't know. I'm just going to say I'm not totally down on it yet. We just need some more time to see it carry out. But we expect Orchard 2 in particular will probably show, if we stay at the rate of return that we saw in 2011, and we don't have a frost, we don't have a hail, about 2 years we'll reach break-even point. The other thing that we're excited about is the new orchard, we call it Orchard 4, with the scab-resistant varieties. because the profitability is going to completely change if you can take the scab or take scab out of the equation, but also the materials that we spray against the scab that very possibly weaken the trees and reduce yield and reduce tree growth. So we're really feeling good about that one. Those trees look beautiful. I was just looking at them yesterday, and they look wonderful for trees that have been in the ground for 1 year. So I have high hopes in there.
Okay, thank you. We have time for a few more questions. I just wanted to say also that you will all be receiving a follow-up survey by email later on today, and if you could fill that out, we would really appreciate that here at eOrganic to give us your feedback on these webinars. So let me ask several more questions because we have time for a few. I'll try to do them as quickly as possible here. Let's see. Okay. Were you using ILLC and sulfur together for scab infections, pre and post infections? And if you could talk about the rate, and also this person wanted to know if you used LLC for apple thinning.
Yeah, that's a good question. There was only once, I think once early in the, back in 2009 that we used them combined. And that's just off memory. It would take me a while to dig through my spray records. But generally speaking, we use one or the other. And the reasoning for using liquid lime sulfur that we've settled on now, we've been trying to get more and more away from it and use wettable sulfur or micronized sulfur in lieu of liquid lime sulfur. And that's for a number of reasons. It is pretty hard on the equipment. I've seen a fair amount of, it had some rust issues and some other problems, filters breaking apart. And it stinks to high heavens, and so it's not an ideal material. And the literature does suggest that it might be a little bit more phytotoxic. We did see some burning of fruit a few years ago when we applied it before a hot spell. But so generally speaking, we use one or the other. But when you're doing that, if you're preferring micronized sulfur, then the problem there is that it has no post-infection activity. So you're sometimes applying before a rain that you're expecting, and the rain might or might not come, or it might not have been enough for an infection period. So you might be applying, more often than would be if you had a, wizard's eye view of the weather. That's kind of the dance you do. But typically, we typically use lime sulfur mostly for its post-infection activity. So if we're applying a material, say with a wetting, like in 2011, when we would have a wetting period that might have had 2.5 inches of rain and 4 days of wetness, you can pretty well assume that there has been no coverage on, there's no residue from a previous spray after the first day, and then you've got wet leaves for the next 3 days. So we would use lime sulfur in that situation, and we kind of decided this year to use it only in that kickback situation. So the idea would have been that it would have been minimally used, but we had such a wet year, literally with flooding in an adjacent orchard, that we did have to use it more often than we had hoped. We have used it around thinning time, at a time when it would have efficacy as a thinner. We haven't used it in, again, in a replicated trial, so it's been used on the larger trees in particular, where hand thinning is particularly difficult. But we still hand thin even on those larger trees, even after we apply lime sulfur. So it's not a one-shot thinning material, even though there's 1 or 2 studies that show it works as well as carbaryl does in non-organic orchards. We still spend quite a bit of time hand thinning. The good thing about hand thinning is it gives you a chance to kind of cull over your fruit, and especially in terms of reducing puncroculio and especially European apple sawfly damage. So there's a really added benefit to getting in there and selectively culling out the fruit by hand. And we don't just drop the fruit on the ground. We collect it in picking buckets and we truck it outside the orchard and dispose of the fruit elsewhere, so that we're not just picking the larva off and dropping it on the ground so it can pupate. So where liquid lime sulfur might work, I feel it does have some efficacy, but it's certainly not a magic bullet as a thinner.
Okay, thank you. Okay, we just have a couple more questions related to soil management. One person wanted to know whether you prepared the soil before planting, and I guess another wanted to know some comments on soil management, and a third person had a soil question, which was, how do you think that the soil microbial community relates to disease management, health of the orchard, investments in sprays, and IPM treatment? So if you could discuss soil management a little bit.
Sure, sure. I'll refer to it in the two different orchards because they've been managed very differently. Orchard 1, which was newly planted, up until 2000, I think it was 2000, the fall of 2003, we removed the orchard that was there prior. So we were planting into previous orchard ground, and we had to do some work to manage the soil, to prevent apple replant disease. So we spent 3 years cover cropping the orchard. Probably would have been 2, but we had an extra year there where we we're working on this grant to get this project started. So we did do a pretty intensive program of cover crops, and I'd have to look back to my records, but I know that there was buckwheat, crimson clover, oats, and vetch all involved over multiple years, plowed down, reestablished. So yeah, we did pretty intensively prepare that soil. It was limed. It was, I think we did everything right for the most part, except, interestingly enough, in that orchard we have identified a restrictive plow pan under that, and that's probably because we spent 3 years basically field cropping that orchard. But that plow pan since it's been planted in 2006, Dr. Heather Darby, who's our soil management person on this project, has been collecting data throughout both orchards over the years. And we found that surface hardness has decreased in both orchards in the tree row, mainly because we're not driving tractors through there, and we've had time for the tree roots to penetrate and break up that plow layer. So yeah, we did pretty actively manage the soil in there. Orchard 2 is a little bit different. Orchard 2, right up until 2005, was a conventionally, non-organically managed 18-year-old, semi-dwarf apple planting with an herbicide strip and everything you would see in there. So what we did in terms of managing the soil, and we didn't do anything different because the trees were already there. They had received, conventional applications of nitrogen and whatnot over the years. And the organic matter was relatively low in that orchard. I can just give you quick numbers. In 2007, which is the second year of the project, the organic matter was 2.2% in Orchard 2, which is fairly normal for our farm. It's a very, very sandy soil. We don't have, it's not naturally high in organic matter. Orchard 1 that same year had a 3.8%, so you had about 50-60% increase over Orchard 2, and it's the same native soil. I mean, they're only the orchards are only separated by 30 yards, but that I think is because of all the intensive cover cropping we did. Looking over, so the soil is tested, not just doing normal chemical tests, nutrient tests every year, but we submit the soil to be tested through a Cornell soil health test, which is more of a multifaceted soil test that covers physical properties, aggregate stability, surface hardness, subsurface hardness. There's a biological component to it where it measures active carbon, root health, potentially mineralizable nitrogen, which is nitrogen in the organic matter. It's kind of an indicator also of the microbial community in there and how well that community can release the nitrogen. And actually, every year, aside from the first couple of years, depending on the orchard, I know certainly in Orchard 1, we kind of fell in the medium scale of that, mainly because of the compaction issue, and because we have low water capacity because it's so sandy, and we had, we were somewhat compacted from all that extra field work. But we've actually seen the soils have improved every year, and we have not seen an increase in copper, which we spray typically once a year, mainly over concerns of fire blight. We have to document if you're using copper, or sulfur, you have to document for organic certification that they're not increasing in the soil. And actually, our orchard is a little bit deficient in copper, both in the soil and in the trees. So it's not like we're plastering it to the point where we're throwing off the soil balance. If you look at the 8 pounds of copper we use per acre per year compared to the however many million pounds are in an acre of soil, it's fairly minimal. But yeah, we have seen improvements in the soil, particularly in the organic matter. It's increased in both orchards as the sod has grown in. To orchard 2, it's just a mown sod cover, so we just have a mower with a swing arm, and we just mow the cover, and it's just native cover that came in, so it's a mix of grasses and broadleaves. And so we've seen in orchard 2, we went from that 2.2% organic matter in 2007. We're now at 2.7%. So we had a 25% increase, and that's without adding. We've never added compost in there because actually our phosphorus levels are high enough to kind of limit us from adding compost. Orchard 1, where we've been mulching fairly heavily, we've gotten up to, in 2010, we had 5% organic matter in there. So I like to think that we've improved the soils in there, and hopefully that answers the questions.
Okay, yeah, I guess the last part of the question was the microbial community's relationship to disease management and IPM.
Right. Well, that's something that we haven't been able to measure directly in that orchard, and that's something I want to explore a little bit in the future. Is moving a step. The Cornell soil health tests give you some indicators of the microbial community, but maybe moving up to do some of these soil food web tests, which will actually measure the fungi-bacteria balance. So I don't know. I can't speak too much more to it than that because we haven't explored it too much deeper, but we are probably looking to include that as a little bit more in-depth component in the future.
Okay, thank you, Terry. We are unfortunately running out of time, but if you have additional questions that haven't been answered, I strongly suggest that you visit the OrganicA website. The address is there on the screen. If you are interested in attending additional webinars, we're offering quite a few webinars here at eOrganic over the next few months, and you're welcome to attend them all. They're all free and open to the public. If you register in advance at the website that's on your screen, extension.org/organic_production, we have webinars on a large variety of organic farming and research topics. I'd like to thank Lorraine and Terry for presenting for us today and answering questions, and I'd like to thank you all for joining us.
Thank you.
The organizer has